Hello and welcome to a presentation on a bicycle traffic management system based on AI, which I've built. In this video, I'm going to show you how I've built this system, why I built this system, and what it can do for us. As we know that when we are out and about in a car, or if you're walking, or if you're driving, you have to stop at lights. Red light, you have to stop if you're driving or cycling or walking. We all know that. So this system I've designed especially for cyclists, so they will have to face fewer red lights when they're passing through. What the system does is that the system is mounted with a camera, with a live feed of the bicycle path, I should say, and it will detect when there is an oncoming cyclist approaching towards the traffic light, and then it would be smart enough to know that yes, I need to turn the other lights red, and then give this oncoming cyclist green light. Now in this system, I don't do the other parts of the other lights. It's only for demonstration that we can certainly control the traffic light for the cyclist when the system detects there's a cyclist coming towards the light. So this means that the cyclist doesn't need to stop or slow down, because the system would turn the other lights red and give you a green light. So that means you don't need to stop at the light and push a button and wait for the other lights to turn red to give you green. It will detect that you are approaching, and then it will do that for you, so you don't need to stop. So how I build this system? So this is a neural network system based on AI, and in order to coming up with the idea was pretty easy, but implementation took a lot of time and process that I had to go through to achieve this model. First of all, I had to create a sample data, and which contained a lot of images of empty roads and bicycle paths with and without cyclists. So I came up with 40,000 still pictures, which I converted from recording a video, because as you know, a video is recorded on 30 frames per second. So that's 30 pictures per second. So I had to stand and record the road with and without a cyclist. Then I had to separate them into different folders. And then I had to do a model training. So the system, the neural network, will identify what is it really I'm trying to achieve. And at the end, when the training of the model with the training data is finished, it would give you a prediction of whether the new image coming in, it has a cyclist or not. So what tools I used? These are some of the tools I used. There were a few more, but these are the main tools that I used to come up with this model. And how this model works is that the neural network works in layers. So all these neurons, they contain certain value, and they pass on value from one layer to another layer, and then to another layer, and at the end you see the last at the right, you can see one neuron, which will be your answer. So the answer will be either yes, there's a cyclist in this picture, or there's no cyclist in this picture. And then from that, I can control the lights mounted on my system. For my system, I'm using Raspberry Pi, so it's meant to be something that you install outside on the pole. So let me show you the setup and show you in action. It's very exciting. So what you see on the screen right now is a Raspberry Pi, which I have the 400 model, comes with a keyboard. And here you can see these are some pins that come out of it, and there are these lights. So as you can see that these two lights will be operated when it sees a cyclist. So let me just show you the video there. So this is a video feed of the bicycle path, and on the right you can see there is a list of red light text. This means the light should be red, and if you see the small video here, I can see there's a red light. So this is actually a red light, and this is a green light. So the red light at the moment is on because there's no cyclist present. As you can see in this video, there's no cyclist. There was a cyclist, but it's gone. So the light now is red, as you can see, and the green light is off at the moment. You can see it's off, and also in the text you can see it's a red light. So let's wait and see to see what happens when there's a cyclist coming, and then whether this light turns to green or not. So we have to wait and see. We still have red light at the moment, which is fine. The video is a little bit in slow motion because it runs on a Raspberry Pi. Maybe this slow motion thing may not be an issue when you're doing a live feed. I'm not sure, but it's this text that you see and the response of the lights, they are on the spot, so that's not an issue. So as we can see, the cyclist is now approaching, and I now expect the red light to turn into green light, which is going to be the other light, which is off. And this is really amazing because it's not just an object detection. It's object detection at a particular distance, that when the bicycle is a little bit closer, it's when it's activating the light, which is amazing. So I think there's only one cyclist coming, and this should be pretty easy. Okay, yes. And once the light turns green, I will keep it on for the next 5 seconds because it gives the cyclist time to pass through the green line, green light. Okay, there are 2 cyclists actually. Okay, so we have a green light, and as you can see, there's a counter which is at 5. So every time it detects a cyclist, I've set in a variable for 5-second delay before it goes back to the red light. So as you can see, the light is green at the moment, and the countdown timer is still stuck at 5 because it's still detecting an oncoming cyclist. So there's no need to turn to red at the moment. And even if there was no cyclist, it will be 5 seconds delay before it goes to red. So after this guy passes, we should see the countdown timer to go 5, 4, 3, 2, 1, and then red light. So we can see here again, it's a green light. Okay, green light still detecting. As you can see, it says I saw a bike and I'm gonna turn to green. So now there's no bicycle. So now you can see, now it's gonna go turn to red. Exactly. So this is a system which I built. It works amazingly well. I did put in a lot of time and hours to build the system, but it works exactly how I wanted it to. Let me just go back to the presentation and we will close off. So what did I learn from this project? I learned that the neural networks can pretty much do anything, but you have to have data, lots of it, and very good quality, high quality data to feed into the system, to train it in a way that it can do what you want it to do. It's a very time consuming process because you have to think about how you're going to design your neural network, and then you have to try it to see if it's going to work or not. When you are processing and training the data, you have to have a very fast computer. So that's something you need, and that can help you save time. Otherwise, it takes a lot of time to process the data. Lastly, what I learned with this project is that with the help of neural network, you can pretty much save the world, because the potential for it to solve anything that you can think of, it can do it. It doesn't need to be picture-based problem. It can be any kind of problem, and you can be sure that it will know how to solve that problem if you design it correctly. If you train it correctly, it will do exactly what you want to do. So I want to thank you for being with me in this presentation, and I'm going to leave the project link to the description, and you can download and test your cycle video if you want to try out my model. Thanks for watching. Take care. Goodbye.